I say. Yeah. Okay. All right. Let's see. The person who doesn't lose their marbles, that's what's happening in the game.
Disqualified. You done messed up, Aaron.
Okay. All right. Let's see. Okay. And let's make sure all our chats are working. I finally got my YouTube scheduler to work. Dope.
That's dope.
I was up till 5 a.m. trying to get a karaoke thing to work on a Raspberry Pi. That was my last, like, project. I don't know. I was just kind of bored last night. I couldn't go to sleep. And so this is what I was doing. So for Burning Man, the camp I'm going to, they like doing karaoke, but they wanted something that's kind of bulletproof for not needing the internet and also like not overheating and stuff in the desert. So I know I had a Raspberry Pi, and I thought, let's see if I can use codecs and Claude Code and whatever to create a lightweight karaoke software thing. And turns out it's harder than I thought it was gonna be.
Bruh.
So I've been kind of working on that. That was my project last night. Anyways, all right, let's see. Let's go to the live queue. Again, if you want to submit a question, actualofficehours.com. That's where you go. Give us a screenshot. We'll work it on. We'll work on something. Let's see. How does Ace have 1,000? Oh, Ace submitted this 3 hours ago. Okay, technically you're not allowed to do that. Technically, I should clear the queue before office hours starts. So you can't just rack up tons of votes. But I'll allow it this time, Ace. It's okay. All right, let's spin the winner. See who's gonna win. This time it's dude. If Shadow Band gets picked, then this is seriously rigged. Yeah, no, it's gonna be him. Okay, Ace. All right, Ace. All right, we'll do yours. Shadow Band, you're probably next for sure. Look at that, votes, and he's hitting the upvote button. Boom, boom. This is a chemistry question. I kind of like that. That's fun. Okay, consider the data for the reaction shown below. The rate of reaction moles per blah 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 is. There you go. So here's the rate. Can we get a downvote button just for breasticles questions? I like breasticles questions. They're math. You should like them too. You know you like them, Jeff. Okay. Determine the rate law expression. R equals K, A to the M, B to the N, show your work. Yeah, great. Okay, cool. Yeah, so what we're told, right, is that rate is going to be equal to some rate constant, K. And then we have this, these are concentrations. And so, let's see, we have a bunch of stuff here. We got P, Q, and R. So this is going to be the concentration of P, let's say to the M, Q to the N, and then R to the, you guys want to do to the O? That's kind of a 0. I don't like that one. If anything, I need a downvote button for everyone else to fight the shadow ban. Hard problems aren't supposed to be quick, though, Jeff. Yeah, but I learn a lot. Okay, let's see. K, M, N. I'm going to put W here. I just need another variable. Okay, cool. So, we're trying to figure out what all these different exponents are. And we're given a bunch of cases. So that's actually really cool. In terms of solving for this from a mathematical point of view, do you see I have I have 3 unknowns here. I also don't know these things, but we're going to leave those as variables at the end. These are the only things I need to get numbers for. So I think I need at least 3 equations. And these are basically equations because they tell me, oh, when P is equal to this, Q is equal to this, and R is equal to this, my rate is this. Actually, there's 4 unknowns, right? There's K, M, N, W. We don't need values for this. So that's 4 unknowns, 4 equations. It's solvable. It's not linear. but I'll show you. It's an exponential trick. All right, so the key thing here is we need to pick out pairs of reactions where everything but one of the concentrations are the same. I'll show you why we do that. So I suggest logging just because I'd suggest logging. Yeah, logging wouldn't really work here, though.
Bruh.
Maybe at the end, I guess it would. It's actually simpler than that. Let's look at, for instance, trial 1 and trial 2, which has the Q concentration being the same and the R concentration being the same, but the P concentration being different. Okay, so let's write out, for instance, trial 1. Trial 1 has a rate which is equal to 0.00242, and that's equal to K. I don't know what K is. And then we have the concentration of P, which is 0.1, to the M. I don't know what exponent it goes to. This is called the order of the reaction, by the way. All right, Q is also 0.1, and that's going to be to the N. And then we have R, which is 0.02. And that's to the W. All right, now let's look at reaction 2. Reaction 2 has a rate equal to 0.00483, and that's equal to K times 0.1, times 0.2 to the M. Right, so if we look at this reaction, P is 0.2, but then the other ones are the same. So then we have 0.1 to the N, and then 0.02 to the W. Bro's doing rate equations. Yeah, I am doing rate equations. That's the question that has been asked so far today. You can also submit a question if you want. Actualofficehours.com. We'll go do it. You're taking diff next semester. Diffie Q. Any suggestions? Any advice? Definitely review like how derivatives work, I guess. Be really comfortable with that. You gotta do a lot of derivatives. So M is equal to 1. Yeah, I think it will be. Let's show why, though. Okay. So if I were to take equation 1, and then I were to divide it by equation 2, right? If I were to divide these two by each other. So let's take this whole thing. And then, so I'm going to show you mathematically how this works, and then we're just going to do the shortcut. I'm not going to write everything out for every single one. It would take forever. Okay. If I divide these two things together, right? Notice what happens. I have a K on the top, a K on the bottom. So the K's are going to cancel. That goes away. I have 0.1 to the N, 0.1 to the N, so that cancels as well. 0.02 to the W, 0.02 to the W, that cancels as well. What's the Heinz? I've never heard of the Heinzman method. Okay, so then all that's left, right, is this. So you're going to have 0.00242 over 0.00483 is equal to 0.1 to the M over 0.2 to the N. And then this is, or sorry, to the M. Sorry, they're both to the M, not different variables. Sorry, my M's and N's look the same. This is the same thing. So 0.1 over 0.2 all to the M. And then 0.1 over 0.2 is equal to 1/2. So 1/2 to the M. So then I got to like compare, right? What is this? Well, if, for instance, you were to take your calculator out, nothing's ever going to be like exact, but it'll be pretty fucking close. The ketchup method? Yeah, is that the ketchup method, Juan? The Heinz method? If you take your calculator out here, let's do 0.00242 divided by 0.00483. I get 0.501, right? Very, very close. Okay, so this is like 0.501 is equal to 0.5 to the M. So what is M? Well, M is just going to be equal to 1, right? Because effectively, this is basically the same number. And the only way 0.5 to the M equals 0.5 is if M is equal to 1. The other way to kind of look at this, right, which I think someone has kind of already drawn here, they looked at, for instance, okay, if I'm comparing between trial 1 and trial 2, and everything else is held constant, this doubles, and then this also doubles. that tells me that this must be to the first power. It must be linear in terms of p, right? If I double p, I get, so if I double p, I get a double rate. No, this is chem. Okay. So right away we know m equals 1, right? Let's try to go find the other variables. So let's go find n. So n is finding q. So what I need to do to find q is I need to find two situations where q is different, but everything else is the same. Because when everything else is the same, such as in this case, right? The q and the r's were the same, we can just get rid of them. And then we only care about, how much is this jumping? How much is the rate jumping? What's the relationship? So let's see. I think from what I see here, they use equation 1 and equation 3. Let's see if that makes sense, right? So from 1 to 3, yes, p's are the same, r's are the same. So let's just look at what happens to q. Q doubles. What happens to the rate though, right? Notice how here between reaction 1 and reaction 3, that rate's going up by a factor of 8. Okay? So when Q doubles, and that leads to R going up by 8, we can kind of think of like what the exponent must be. So in that case, the exponent is going to be 3. And the reason for this is that 2 to the third is equal to 8. Let's remember, right? This is Q to the N. And we would say, like, is proportional to R. And what we know is that 2Q to the N is proportional to 8R. So then, if you multiply this kind of through, right? Exponent to two things. This is the same thing as 2 to the N. Q to the N is proportional to 8R. Well, that tells me that this n must be equal to 3. Because then 8q to the n is equal to 8r, which is the same thing here, right? We just had 8q to the n equals 8r, yeah. Hopefully that makes sense. Yeah. Okay. So this is really easy to see that n is equal to 3. Let's look at the other one here. It looks like they use the first reaction and the last reaction to solve out what happens to... sorry, I realized I said R here. This is rate. Not... Because there's another fucking R in here.
Disqualified!
That's really mean of them to put R's in two things. Okay. All right. This, between 1 and 4, P stays the same, Q stays the same, R doubles. What happens to the rate? Now the rate goes up by a factor of 4. So if something doubling means it goes up by a factor of 4, then that must mean it's a power of 2. Is this Chem 102? I think it is. Okay. So then W is equal to 2. Because again, what we're saying here is that R to the N is proportional to Q. So if 2R gets you 4Q, that tells me that R must be R squared. Where can we send questions? What's up, Boomer? You can, here, there's a website, actualofficehours.com, but then there's also a link right there if you want. Okay, cool. So we got M, we got N, we got W. Great. The last thing is to find K. To find K, you can just use any one of these reactions and just plug in all the numbers. So let's use this one. For instance, let's use this one to find K. So now we have the same 0.00242 is equal to K, and then all this other stuff is still the same. But now we know all the exponents for the different reactants. So now, yes, M was equal to 1. N was equal to 3. W is equal to 2. And now we can just solve for K. So this is easy. So you get 0.00242 over, that's going to be 0.1 to the 4th times 0.02 to the 3rd equals K. We can solve for that. Let's just get it. So 0.00242 divided by 0.1 to the 4th divided by 0.02 to the 3rd, or sorry, to the 2nd. I don't know why I wrote 3 here.
Disqualified.
I was wrong. I make mistakes sometimes. Okay. And that gets me 60,500. All right, so K is equal to... It's equal to 60,500. All right. We also should come up with the units for this. Okay, this is actually another cool thing that happens. Okay, so I know that my rate... So, rate is equal to 60,500. We need to figure out the units eventually. We will do that. But then it was, what was it? PQR, and then it's 132. Okay, so this was P, Q to the 3rd, R. And to find out the units for this is kind of a reverse puzzle. So the rate needs to be in moles per second, right? I think, yeah. Or sorry, it's mole over second liters. Sorry, this is what it is. Sorry, it's moles per liter seconds. It's moles per second really, and then 1 over liters means you need to multiply by how many liters are there. Okay, this is the rate. This is going to have a rate of moles. This is going to have a rate of moles to the 3rd. This is going to have not a rate, sorry. This is going to have units of moles. This is units of moles to the 3rd. This has units of moles to the 2nd. So overall, this is going to be moles to the 6th. Okay? But I need to only have moles to the 1st on the top. So what that tells me is I need moles to the 5th on the bottom. And then times liters times seconds. And then you put a 1 over it. Yeah, it's just dimensional analysis. Exactly, Laz. Right? So this times this, because if you had moles to the 6 up here, this would cancel out with this, and you just get 1, and then you would get your moles over liters times seconds. So, final is R equals 60,500. And then sometimes they'll say moles to the -5. Liters to the -1, seconds to the -1, and then just this PQR 32. And then if they ask you what order the reaction is, you would say it's 6th order, right? So this is 6th order. And there you go. You're done. That's how you do it. It's a fun chemistry question. A lot going on that one. But okay, great. Okay, so this was aces. Mark it as done. Every question we do goes into our Discord, so make sure go join our Discord if you want to like stay up to date with all the fun activities we do, and also to get screenshots of all the homework questions we go through. If you ever want to like go reference them again, that's going to be here. And then also there's a link to the YouTube channel where it is. The recording for it. But good question, Ace. Okay, cool. All right. You're not late. What's up, JBL fan, Alistair? Alistair, are they doing another season of Has Been Hotel? I really like that show. It's quite fun. Definitely adult themed. I'm confused. Some of you students watching it as like high school kids. It's pretty adult. But I really like the animation style. It's kind of cool. All right, let's see. Ooh, we got some good questions up here already being submitted. You saw some parts of it? It's definitely kind of adult, yeah. The jokes are very adult at times. All right, let's spin the wheel. See whose question's going to come up next.
Let's go gambling!
Wow, he's not shadow banned.
That's dope.
Wow, look at that. Look at that, breasticles. You're not shadow banned, dude.
I think that means that I am.
Oh,
Because
actually,
last time when I was breasticles, I got like shafted by the wheel.
You got absolutely
Vicious.
shafted yesterday. Viciously.
But
Question didn't get picked the whole 2 hours.
exactly.
Absolutely diabolical.
And now that's why the question even includes difficult in the question.
Okay, great. All right, what am I doing here? There's another page.
Yeah, those are it references to a example one, which is here, and then and then
Okay,
the
looks like
diagram
are we doing orbits?
kind of. This is it also explains a bit in the other photo, the one on I don't know how to pronounce that. Bifurcation.
Bifurcation?
Bifurcation. Yeah, bifurcation.
Yeah, bifurcation. Bifurcation's cool.
So.
Okay.
And that just kind of explains it. But our goal is to do number.
Number which one? Number 3?
Number 1.
Number 1 says difficult.
Indeed, it does.
Okay. All right. Fine. Okay. Cool. We'll do this one. Heads up to those that are watching the chat. If this is confusing or makes no sense to you, it's totally okay. We get questions from all levels. So stuff as simple as like middle school adding fractions to high school level chemistry or calculus to this, which is, what would we call this? Partial differential equations?
Yeah, this is from PDE.
This is PDEs. So this is like an upper division math class in college.
And this is the very end of the book.
And this is the very end of the book. So it's going to be really difficult.
Yeah.
So
if you turn the page, one page from the exercises, it's the appendix.
Oh damn, we're literally at the edge of the earth, right? We would fall off to the flat part.
Yeah, you would just go into the infinite waterfall at that point if we kept going.
Yeah, infinite wonderwall. Yeah. Would elementary work be accepted? Yeah, we've answered all sorts of stuff. So, anyways, hang tight, guys. If you don't understand it, it's cool. You might pick something up along the way. I'm definitely gonna learn some shit. So let's see. All right. Derive the bifurcation diagram for example 1 by integrating the ODE as explicitly as possible. Okay.
Mm-hmm. And then that, if you scroll up.
You want me to go up? Yeah.
Yeah, that top one is your bifurcation diagram. That's your differential equation. And then if you scroll down, it just explains what example 1 is. In
I
the
see,
other
okay.
picture.
Okay, so cool. Yeah, so let's talk about like what bifurcation means. Bifurcation, yes. Bi means 2, and to like furcate, like means to split. Mm-hmm. So bifurcation is how solutions depend on parameters, and then how if something is one value versus the other, like what's the breaking point that splits it into 2 different paths. Anyways, okay. A trivial example is afforded by the eigenvalue solution u to the n is equal to lambda u with u equals 0. The solutions are lambda equals n squared with u equals c sine nx. Okay. The picture is all the solutions in the lambda c plane. Okay.
Yeah, and I think that's the one right above it that it's explaining. The first part is just explaining what.
Oh, it's describing this.
Theory is. I believe so. Yeah.
Okay, cool. All right. Let's see. If nonlinear terms are present, they will distort. And there can be also many... Oh, this is very cool. So, for instance, you could have something here where solutions like split from here to here, I guess. And then it's like, oh, but if you take this path, you can either do this or you can do this. It's like a choose your own adventure type thing, right?
Yeah. It kind of has to do with like, your stability and how things vary with that.
There's also like hysteresis and shit. Like your previous decisions affect the future ones. Like there's memory. You heard that before?
Yeah, that pops up sometimes in fractional
circuits,
differential equations.
Ooh, fractional differential equations. Okay, very cool.
Yeah, I forget exactly, but I was looking into it one day. But certain fractional derivatives have a memory. I call it a memory, like a memory cell, where your previous actions affect how it behaves, not just how it acts in an instant.
It's like how it happened as well. Yeah. So these are like paths you can take on life. I don't know. You could decide.
Yeah, kind of.
I want to go to college, or I don't want to go to college. What happens? Actually, this would be the path of like I go to college. This is a path like I don't go to college. If you go to college, your life can also like blend in a lot of different ways. If you don't go to college, not saying you have to go to college, but there's probably less options for what you can split off into. Or maybe more. I don't know. At this point, I don't know if I can really like recommend college for certain things. Okay. A rod is subjected to a compressive load, okay, and bends as shown. For instance, it could be a vertical yardstick resting on the ground with, okay. Oh, I see. So you're saying you have like a stick here, and then you start compressing it, and it causes it to bend up this way?
Yeah, in essence.
That's cool. Okay. All right, so when that happens, let ux be the angle of bending under reasonable assumptions about the rod. One can show that d squared u dx squared plus lambda sine u is equal to 0 when x is between 0 and L. And at 0, I guess, it's equal to 0 is equal to d dx of L. Okay.
Oh, yeah, that makes sense. It's saying at the angle of...
The angle of bending at the endpoints is 0, or the rate at which it's changing?
Mm-hmm.
Okay. Okay. And so then this is the differential equation we have to solve?
Yes.
Oh, okay, cool.
And we just have to, from there, replicate the diagram.
Okay. Cool. Let's try to do it. D squared. I'm gonna copy this. I think I only need this. Okay, so this is what I need to solve. And they say the parameter is lambda. We can linearize it, replacing. Okay, so they replace sine with a series representation. Simply. By replacing sine u equals... This seems too easy. Sine double prime is equal to sine. But it's the derivative of u. And then this is a sine u.
Yeah, it's not that easy since it's...
Okay. All right, here. Guide me, breasticles. I don't know what to do here.
Okay.
I'm confused.
So the first thing that you're going to want to do is you're going to want to multiply the entire differential equation by a u prime.
By u prime. Okay.
Yes.
Okay, so we're going to multiply. This is always so funny how differential equations is always techniques you use when shit looks like something you recognize. You say, oh, in this situation, I'm going to multiply by an integrating factor. In this situation, I always wonder how people came up with the strats.
I do too.
How the fuck they come up with this?
Half the time I look into it, I kind of figure it out, and then I forget it eventually. And then from here, if you take a look, if you pull out your derivative operator, you get ddx, and then it's 1/2 u prime squared minus lambda cosine of u.
Ooh, one sec. Okay. So instead of saying the second derivative of u with respect to x, you want me to do d dx of du dx? Is that kind of what we want? Oh, but then this is also u prime.
No. So you want to, well, kind of. You're gonna pull your d dx from the entire.
From everything. Oh, we're just gonna realize this is a cute
everything.
chain rule or something.
In
Or a
essence,
product rule. Okay. Okay. So, one sec. Let me think here. Sorry.
Yeah, so you had the right thought with the ddx du dx,
Okay. U
right?
prime.
Because you'll have a u prime times a u prime.
Yeah.
And then similarly, you can pull out your ddx from that as well.
Okay. So then this would be ddx of u. Well, I don't agree with this though, right? Because this is gonna get me a cosine u prime, right?
Yeah, it becomes goes from plus lambda sine of u to a minus lambda cosine of u.
Let me think. Because then I'm gonna pull this out from both, is what you're saying?
Yeah.
Okay. So this is gonna be u lambda cosine of u? Or negative?
You don't need the u there in front.
Oh, you don't.
Because by the chain rule, when you take the derivative
Yes,
of your cosine,
you're gonna get a
your
u prime.
prime's
You're gonna
come
get a
out.
u prime. Oh, fascinating. Oh, this is fucking dope.
Surprise,
And then
motherfucker.
you should also
Okay,
have
but there's a minus sign. There's a minus sign. There should be a minus sign, right? Okay, let me show for people like what happens here, because I mean this is related to calculus. Lewis says, is a 1030 out of 1440 good on the PSAT? I don't know about PSAT scores, honestly. Are they out of 1440? That's weird. Why aren't they out of like 1600?
You done messed up, AA.
1440? Why
I
1440?
think 1440 sounds correct because I know a 1390 is pretty good. I remember we had this one like super stoner kid in high school who like skipped class all the time, never see him, like didn't do anything. Everyone was like, oh, he's gonna fail the SAT, he's not gonna do shit with his life, and then he scored like a 1390 on it.
Which I guess is really good because it's close to
Yeah, because I think
1440.
it's out of 1440.
Okay.
But I think that's good for a PSAT.
Yeah. It says it's,
If you
yeah.
going
Presco
up.
says
I mean,
pretty
I never-
decent for PSAT.
When I took my PSATs, I think I was around like a 1080 or a 1090, and I just went up by 100 every year. And I didn't really study for it. But
I didn't, when I
It was
took the
good.
PSATs when I was in high school, I didn't think it was a real exam. I thought it was just a practice, so I just fucking like blew. I just joked on it. I was just like, whatever. Like, what are we doing here? And then I didn't realize it was pretty necessary for like scholarships and stuff. So I would have probably taken it more seriously if someone told me that. No one told me it. No one told me that PSAT actually meant anything.
yeah, I don't think anyone did for me either. I knew if I didn't try, my parents would give me shit for it. So
Yeah.
it wasn't making energy to fake it. I had to be there anyway.
Yeah. What's up, Don? A raid from the legendary bearded man, Don Factorial. Let's go shout out Don. Don's great. Love Don. Don, what was Don? I feel like you were doing PDEs in your own stream, weren't you? We're doing some PDE questions, some non-linear PDEs right now. Bifurcation stuff. But okay. So I guess we're trying to solve this just to catch people up with like what's going on. We're trying to solve this. And what we were realizing here is I can write u prime lambda sine u as the same thing as the derivative operator ddx of lambda cosine u, and that's because if you were to do a chain rule here, the derivative of something with respect to x is gonna this is gonna be the same thing as d du times du dx. It's the same thing as this operator. It's the chain rule. Derivative of cosine is sine, or negative sine. And then we have to take the derivative of what's inside, and that's where the du dx comes from. So this whole thing here, which looks like, remember u prime is du dx. So du dx lambda sine u, du dx lambda sine u is just equal to the negative d dx of lambda cosine u. What's up, girl? Girl that is small. It's a very unique username you have there, girl. Cool. What's up? Thanks for the follow, by the way. You dope.
That's dope.
Okay, so now that I have this, I can pull out the DDX from both, yeah? That's what we're gonna say?
Mm-hmm.
I always love when we can just treat operators as things that can just mess, just move around algebraically.
I mean, you
started-
kind of can.
I feel like I'm doing something
Kind of.
wrong when I do that. I'm disobeying. I feel dirty. I don't know.
As long as you don't necessarily treat it like a fraction.
Yeah. They didn't like my trick for solving what was it, for solving implicit differentiation,
Yeah.
where if I did like 3x squared y is equal to 2, I would say like, oh, this is 6xy dx plus 3x squared dy is equal to 0, and then yeah, just divide everything by dx. Yeah, that's all you gotta do. Like, no, you can't do that.
You see, I just like explaining it as like, you write it as d by dx, and then whatever variable it's acting on, it's just like multiplying it
Sure.
visually. And then
I guess it's interesting though when you have a third variable. So if you start introducing dt, right? If the derivative, if it's now like dx dt dy dt, then I'm like, oh shit, now I need to put like another derivative thing in it.
at that point, I pull out the total derivative from calc
Yeah.
and take partials. It's
I think
easier.
I still don't understand, after my 20 years of teaching, what the difference of this and this is. I feel like they're the same thing. You just like ignore the other variables.
Yeah.
It's just reminding
It
you
just
to ignore
comes
the other
from-
variables.
Yeah, when you like if you plug it into the limit definition, since it's of multiple variables, it becomes like an f of x comma t plus delta t, and then so the x doesn't matter at all.
I see. Girl says, thanks, but I can tell you that I might be small, but my numbers are big.
My man.
Nice. Big numbers. We like big numbers. All right, so we're at this point. Cool. What's my next thought? What's my next play? Well, first of all, this is another... Wait. This
Yeah,
is
that
another...
becomes u prime squared.
Yeah,
Or
right?
no,
Because this
it
is
becomes
this is du dx squared then, right? Because this is the same thing as du dx.
yeah, and there should be a 1/2 in there.
Wait, where'd the 1/2 come from?
When you take the derivative, it's gonna pull down the 2 from the square.
Oh, okay.
Right, like if we were gonna go check our work.
Oh, I see.
factor
This needs to
up
be,
front.
yeah, this needs to be ddx of u of 1/2 u squared. Okay.
Yeah.
Because ddx of 1/2 u squared is equal to u du dx, and right, that's exactly what I need.
Yeah.
Yeah. Okay. Cool. Fine. Okay. So this is ddx of 1/2 du dx, but then this is all squared, and then minus lambda cosine u. What's up, video game wizard? You like Googleologist? Yeah. A Google, I think, is like, is that 10 to the 100? A Google? 100 to the 100? What's a Google again? Some unit. All right. So now we're here. What do we do next?
Now we can just integrate.
Now we just integrate.
Yeah.
Okay.
Yeah, because we're just taking the answer.
Well, I mean, integral of dx is just fucking 0, right?
It should be c.
Plus c. I forgot. Yeah, I forgot that. So this would come over here, and then we would integrate. Yes, the integral of this is technically 0, but then it's plus c. And then the integral of this is just what we had. Can I write u double prime? Is that cool?
It's not U double prime.
Oh, sorry, U prime.
It's just U prime.
U prime squared. That's what I meant to say.
Yeah.
A Google is 10 to the 100. Yeah, that's what I thought it was. Okay, cool. All right, now this is a nicer... Did we even get a nicer differential? What did we go from? We went from the second derivative to the first derivative. Okay. Are we going to repeat this process?
No, from here it's we can do it as a separable differential equation.
Oh, fuck yeah, dude. Love that. Okay, cool. So
but actually first we gotta figure out C. I forgot about that.
oh, we gotta figure out C. Okay, fine. Well, what they told me was that the derivative at 0 and the derivative at L is equal to 0. Random dude on Twitch says, "Hey, are you able to do soil mechanics?" Probably not. What are soil mechanics? I can do mechanics. That sounds like a specific agricultural engineering question that might have some words that I don't understand. You can always submit it. I always like seeing the questions. If you ever want to like submit a question to our stream. No, not suit. Submit. There you go. That's the link for it. That's where you can submit your question to our website here, and then it gets entered into the queue. And then click upvote every 3 minutes if you want to increase your chances of getting picked. Okay, let's do this. Geotechnical engineering. Wow. My government name is Geo, so maybe I can figure it out. All right, so U prime of 0 is equal to 0, and also U prime of L is equal to 0, right?
Yeah, and this part I had to go to ChatGPT for this part of this.
Yeah.
Because I wasn't 100% sure. I don't actually particularly know where they pull this out of. But U is going to be equal to P, where P is the maximum value.
Okay. Oh, I think maybe I see why. Wait, U is equal to P, which is equal to a max?
Yeah, the maximum value. For,
how many subs to legally change your first name to Gold? I wanted to change my last name to Gold right before they gave me my PhD diploma, but my mother would like killed me.
Oh no.
I wanted to say like Dr. Gold, like on my PhD, but my parents would be very sad. It would have been awesome, yes. It would have been fucking dope. Okay. All right. P is a max. I think the reason it's a max is because I mean the first derivative is 0, so that's a critical point at the endpoints. And then is the second derivative always positive? Maybe. Well, I guess so, right? Wait. U squared is equal to a positive number.
No, I don't think it is. I don't think the second derivative is always positive. Because if we just rearrange our differential equation
you're right.
from whatever, the second derivative would become negative lambda sine of U.
Bruh.
Okay. What do we do next?
Okay, so from here we can just plug it in, and that gets us C as negative cosine of P.
Okay, so wait. Okay. So I'm gonna say all of this is 0, and this is at X. But I see there's nothing with X in here. We just assume this is 0.
That goes to 0.
We only said that the first derivative was 0 at 0 and L.
Yeah, we're just plugging in those boundary conditions. If we plug it in for 0, because U depends on X.
It does, correct. So, all right, fine. So 0 minus lambda, we're gonna say cosine of P is equal to C. So C is equal to negative lambda cosine of P. Is that what we just say?
Yeah.
Okay. I'll trust it. Seems okay. Okay. Cool. So now I have 1/2 U prime squared minus lambda cosine U is equal to negative lambda cosine P.
Yep.
And now I want to separate?
Yeah, you would want to move your cosine over to factor out lambda as well there.
So let's put it over here, I guess?
No, other way. Move
You put it on the other side.
Cosine of u to the other side, so it's just u prime.
Usually, I
squared
want to keep like one variable all on one side, though, right? Usually, I want all the u's on one side.
Well, we could solve it as a separable differential equation.
All right,
This is
let's
what
see.
we're working towards.
Okay. Oh, I see what you're gonna do. All right, you're gonna pull lambda out. Girl says, I only have a GED. That's okay. GEDs are still good. I have some students in my Discord who haven't graduated high school. And they're in their 20s. And I'm trying to get them to go back to school to go get a GED. So please motivate them for me. Okay, so then this moves over, right? So then I have u prime squared over cosine u minus cosine p. Whatever. I'm just gonna say is equal to 2 lambda. Can we do that? I don't like the 1/2. I think it's ugly.
Huh?
Yeah, that's the right step.
Okay. All right. And then,
Oh, also, one more thing I forgot about that step.
one more
We're
thing.
gonna say using some of our
Oh,
trigon
no.
identity, cosine of u minus cosine of p becomes sine squared of p over 2 minus sine squared of u over 2, and it'll make sense when we do that in a second.
Okay, so this we're gonna use a trig identity.
Mhm.
Okay. So cosine of a minus b is the same thing as sine squared of u over 2. Is that what you're saying?
Yeah, and then it would all be multiplied by 2.
Okay, so wait. So it's 2 sine squared of u over 2. And is it times cosine squared of p?
Minus sine squared of u over 2.
What happened to the p?
Oh, the first one should be a p. Second
Oh,
one
okay.
should be a u.
This should be a p.
Yes.
Crazy.
And then they're all multiplied by 2.
Oh, okay. So like this?
Yeah.
Okay. So let's go write that down. Okay, so then this is 2. I'm gonna put the 2 over here again. I don't like all the numbers there. Make this 4. And then okay, sine squared p over 2 minus sine squared u over 2.
Yep.
Cool.
And then we're gonna say from here, we're gonna call our sine of p over 2 k. Since it's just a constant, so that it just becomes k squared. And then k also, it has to be from 0 to 1, but that's fine. We know that.
Okay, so then this is k squared.
Yep.
Okay.
All right. And then we can you'll probably want to actually move your 4 lambda over to the other side. You don't like the fractions, but
I really don't.
yeah.
Okay, so I'm gonna move that over.
Mm.
This is all equal to 1 then?
Yeah, and then you would also just bring the square root down. So it
Bring the
becomes
square
2
root?
lambda. Yeah, because we would have to take if we moved it all over to the other side and took the square root, so that we would just have u prime. You see what I'm saying? If we multiplied everything on the bottom to the other side,
Yeah.
took the square root, and then moved it back down to the bottom.
Oh, I see. So you're gonna get rid of this, but then put a square root over everything.
Yeah, because we would just have to multiply.
Oh, I
over,
see.
but then we would bring
Well,
it
you could
down.
also do this. You could square root both sides, right? Square root of 1 is just
Oh,
1.
yeah, I guess you could do that too.
Okay. So then we just have this. Okay.
And then
This is technically
we can
plus or
separate
minus
our
1.
variables. Yes, it is.
All right. And now you say we separate our variables. Oh, okay. Because then this
Yeah,
just becomes
'cause-
du dx.
Mm-hmm.
I see. This is a nasty integral, dude.
It's not as bad as it sounds.
Looks
or
fucking
looks.
ugly, dude.
You're not that guy, pal.
It is.
Trust me. You're not
Yeah,
that guy.
that's in a way what makes it easy.
Okay. So this is gonna go over here, And I'm going to be left with du over 2 square root of lambda. And then this is k squared minus sine squared u over 2 is equal to plus or minus dx. Yeah?
Mm-hmm. Yep.
Okay.
And then we're going to say let sine of u over 2 equal k sine of b.
K sine of b?
Phi, like data, but with the line going up top.
Oh. Whoa, what?
Surprise, motherfucker.
Wait, whoa.
Well, that's...
Whoa. Wait, K was sine of P over 2. What? But this was, right? Was this not sine of... This was sine of P over 2, no?
Yeah, I didn't write my in-between steps, but we said... Can you scroll up to the original trig identity?
Right here? You're a good girl, that's small. Thanks for the follow. We stream 4 times a week. Anyone else who's watching, you want to know other times we stream? If you go to the website, go to streaming schedule. There's a beautiful calendar here that shows all the times we stream. Our friends Zach and Penn Center. So we're not streaming tomorrow, except we are going to do kind of a recess game type thing. And then it looks like our next stream will be on Sunday. So come on by if you want to get help. Congrats on getting your GED. You could get it done in a week to a month. It took you 2 years because English hates you. I know, English hates me too sometimes.
You done messed up, AA Ron.
Especially if it's not your first language, girl that's small. I mean, it was my first language, but I know people trying to get their GED who they're not native English speakers. It's tough. What's up, cruising? All right. Breasticles, what do I do? What did I do wrong?
Well, I mean, I'm looking. I know that if we write it like that, it's I know it's correct, but
Okay. I don't speak my mother's tongue.
Yeah, I forget where I came up with that substitution. It was late, and I was working through it with a lot of
It's okay, dude.
So, but it works in some way, shape, or form. But so then if we do that, it just becomes one of our what's it called?
See you on Sunday, girl.
Integrals.
Elliptic integrals. Excuse me? What?
Yeah, there's like a family of like the Jacobi elliptic integrals.
Dude, this boy Jacobi, bro. Okay, so du over 2 square root of x k squared minus k squared sine squared phi. Is that what we're gonna say?
That should be a lambda, not an x.
Yeah, you're right. I don't know why it turned into a lambda. I think I kind of see something because this is going to be the same thing as k 1 minus sine squared, which is then cosine squared.
No, we don't even need to actually solve it. That's what's nice about some of these special functions is...
Really? I feel like this is solvable
that's...
because this is just 1 over cosine, right? I guess the issue is that, yeah, it's just integral of secant, no?
Hold up, I'm thinking.
Cruising says, what kind of... This is partial differential equations. Ooh, girl, what's your system? What's the system? What system are we talking about? Like a computer system? It's okay. You don't have to like explain it. What's the next step? I hope we're like somewhere close to the end.
We write it as sine of u over 2 equals k Sn of root lambda times x minus x naught, comma k.
Okay, SN. I have no clue what SN is.
It's the Jacobi elliptic integral for sine.
Okay. Okay.
It's I'll send you a screenshot.
SN square root of. We're getting to like some crazy math.
Disqualified.
All right, here we go. Dude, anytime I see like of the first kind, of the second kind in math, I'm just like, no. Why are there multiple kinds here, dude? Excuse me? Okay. The Jacobi elliptic functions. I see. That does look like this. I will give you that. Okay. And then we call it SN. Okay, cool. Okay.
I feel like the k squared might have just.
You fucked up on the k squared?
It factors out in some way. I knew that it was supposed to go to an elliptic integral, and I just kind of like skipped most of the steps and jumped to the elliptic integral.
Hand wavy.
Surprise, motherfucker.
Yeah.
Just hand wavy. Okay. So then what is this? Sorry, K SN square root of what?
Square root of lambda.
Uh-huh.
And then multiplied by x minus x naught.
Okay.
Comma k.
Comma k.
Yeah, because our Sn function it's like a two-valued function.
Oh, I see. Sorry. This is what it is.
It would be like
this.
Sn of two values.
I see. Sn takes in two parameters.
Yeah.
Okay. Are we done?
Almost.
Almost. Okay. Almost there.
From here, we figure out the period of the oscillations, because it's oscillatory.
Okay.
And so we get that our period is t equals 4k of k over square root of lambda. And k of k is the elliptic integral from 0 to pi over 2.
Okay. And then?
We're pretty much there. Just now that we know the period, we would say that our lambda is 4n squared over L squared times our k of k squared, just from some simplification.
K of K. Dude, I'm like, what? Why is there K of K? It's like X of X.
That's a great question.
It's a great question. Oh, man. I'm so confused how all of this is supposed to produce this graph.
Well, that's a graph of lambda. So at each point, that's our value of u as
okay.
with different lambdas.
Okay. Nice. Okay. Is there anything past this?
No, not really. We could write our like explicit form by saying that our u of n plus or minus, and then write all of, and it's like a very ugly equation, but
Disqualified.
that's pretty much it.
Okay, cool. I learned stuff along the way. Even if like the ending is still, I kind of like put my hands up. I'm just, like, what's going on? There were some really cool techniques here that I liked. I think getting comfortable with this really helps me too. I enjoy this stuff. Yeah, this stuff is starting to go into like mystery no man's land. But we'll be right back. No, we won't. Where's my? We'll be right back. Getting triggered. There we go. Okay, cool. Did you take this in your ODE class? Was this like a question you had to like do?
This one?
Yeah.
No, we didn't get that far.
This is just
Most
for
of the
funsies?
kids in my most of the kids in my class didn't really like care to go that far. We barely got to Laplace's equation.
Let's go even further
Just-
beyond.
Yeah, kind of lame, but I kept reading it and learning it. Especially
Video games-
when I was like driving from New Orleans to Colorado. It's like
Wait, you would be
16 or
you would be
17
reading
hour
this while
drive.
you were driving? How would you be reading this while you were driving?
I was riding with family, so whenever I was in the back seat,
Got you.
and,
Whenever you're taking turns.
yeah. So whenever like
Feels.
I had a chance and I didn't have internet connection, just pull out this
Fuck it.
book and start reading.
That's cool, dude.
Especially because and also at the time I was writing my paper on PDEs, I think. I don't remember exactly.
It's better than just like doom scrolling through like thirst traps and stuff.
Most of my doom scrolls include math too.
That's great. Yeah, you have a healthy algorithm.
I've submitted some from Instagram, I'm not gonna lie.
Flask is asking, what book were you reading?
This is Partial Differential Equations by Strauss. Expensive ass book, by the way. You wouldn't think it's like that expensive. Well,
Let's
I
go
got
find
it for $50, but I found the original
Dude,
receipt for
Where
it
can you
from
even...
the 90s.
Dude, it's not even on Google. Dude, what?
Yeah, it's I can't find
Okay.
I could never find a PDF. I probably wouldn't have bought the book if I could, but
This is apparently...
it's that red one.
Wow.
Yeah,
An
I found
introduction.
the original receipt from it in 1999. This book was $75,
It's decent.
which is
I remember like OChem books were like
with
300-400.
inflation. Well, this is like a pretty small book. This is like maybe a novel size wise.
Novella.
Yeah, it's not like your usual like big ass textbooks. Maybe 3 pounds at most.
Nice. Okay, let's go choose a winner. Let's see what we got.
Let's go
let's go
gambling.
There we go. Lots of people. Ooh, Lucky Cat. You do hold to your name, Lucky Cat. You had a 16% chance. Look at that. You were the luckiest of cats, Lucky Cat. All right, this is not too bad. All right, given the following analysis of f of x, and we're given f prime of x, f double prime of x. I don't know what this thing is here. Are they just asking you to like kind of like draw what it looks like? I guess we could do that. Okay, so this is increasing. Yeah, pineapple, you won. Okay, it's increasing, and then there's a couple ways it can increase, right? It could increase either concave down, or it could increase with concave up. And this is negative, so that tells me it's got to be doing something like this. And then this is 0 and 0, so this means it's flat. And then it starts increasing again, actually, but then this time, okay, so it starts going up again. But again, it could do concave down or concave up. It's concave up, actually. So this is actually very interesting how this graph is going to look. So this is going to start doing this. This is concave up. And then we get a do not exist. Okay, when nothing exists here, this is most likely an asymptote. So I'm going to draw something like that. I'm going to say, like, asymptote. All right, and then from 5 to 7, again, it's increasing still, but it's concave down. So that's going to mean it's like that. Here it is flat, but the second derivative is still concave down. And then here it is increasing, but also still concave down. This function like never... First of all, this is weird, actually. Wait, what? How does the function keep increasing? How does that happen? How does it keep increasing but also be concave down? There's got to be like a jump, right? No? It's kind of weird. Oh. Actually, no, sorry. This is decreasing. That's what the minus... Dude, okay, this I don't like. Sorry. What is this? Why do they... This line to me makes me think it's increasing. That's a distractor.
Huh?
Okay, sorry. No, yeah, because I was like, this doesn't make any sense. Can't do that. It's decreasing, but it's concave down. Okay, that makes sense. Excellent, got it. Okay, intervals of increasing. I would say negative infinity to 0, union, 0 to 5, and then union 5 to 7. Yeah, I think the line means not given, I guess. Yeah. Intervals of decreasing, that's only going to be here. So we're going to say from 7 to positive infinity. Local maxes, okay. Well, you can actually just see from it, right? You see how this is like this. This is this. This is the only thing that's a local max. So x equals 7. And then, well, if you want the value, sorry, you have to say like 7 comma 4, right? The x coordinate is 7, the y comma is 4. I do have videos on E&M. Yeah, I've done some E&M. State all the local mins. There are none. None. Because nowhere do we have the first derivative being 0 and then the function being concave up. State all the intervals on upward concavity? That's interesting they call it upwards. I guess this is kind of... I mean, I don't know if this is upwards, because it's kind of downwards here. I would say positive concavity. Positive concavity happens from 0 to 5, for sure. And then that's it. Negative concavity. Okay, so that's negative infinity, comma 0. Union... And then 5 all the way out to infinity, because it's still negative here as well. So this is 5 comma infinity. Sketch. They want us to sketch. Okay, fine, cool. You can do this. It's very easy. So first of all, horizontal asymptote or vertical asymptote at x equals 5. So let's do that. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 7. Okay, so you're gonna have 1, 2, 3, 4, 5. I always like graphing the asymptotes first. So there's a vertical asymptote. And then they do give you some points. So at x equals 0, y equals 1. So we can put that point in there. I don't know, I'm like trying to make this evenly spaced. It's not really evenly spaced. Whatever. Okay, so you'd have a point here, 0, comma 1. That's given. You also have 7, comma 4. 1, 2, 3, 4. Okay. And then we can kind of draw what's going on. So I think it's going to do this. We could say that. And then here, it's got to do this. There you go. And that kind of fits from this. I think this was a good thing to draw. You can kind of see what it looks like. Okay, cool question, Pineapple. Did any of these things not make sense? Why is 7 decreasing? 7 is decreasing because the first derivative is negative. And then the second derivative is also negative. So that means it's going down. And then when it's going down, it could either do this or it could do this. Because the second derivative is negative, it does that. It's minus equals plus. Oh, interesting. Yeah, no. First derivative is down. That means it's decreasing. And then you have, it could either be doing this for decreasing. This would be a positive second derivative. Or it could be this for decreasing. And that's a negative second derivative. Does that make sense? Pineapple? Yeah, you don't multiply these together. It's okay. It looks like you should, though. I get it. Yeah, first derivative always tells you, are we going up? Are we going down? And then the second derivative tells you like how you're going up or how you're going down. If the second derivative is 0, then it's literally just a straight line. Neat. Thanks, Artifact. Appreciate you saying neat. That's cool. Okay, cool. So this was Pineapple's question. Great job. Let's mark that one as done. We'll go put it in our Discord. Yeah, graphing stuff is fun. It's pretty cool. So there you go. So there's Pineapple's question. There's the screenshot for it. And then you get a point. Nice. Okay, cool. Let's go find the next question for us to work on. Again, if you want to submit a question to our stream, it's very easy to go do so. Website's actualofficehours.com. Type your username in, drop a screenshot in, hit upload. While you're there, go join our Discord. That's where we have a lot of fun activities, games, prizes. If you need help after the streams or when we're not streaming, we also give help. And then there's also a calendar that has all the other... I'm not the only person that does this. A lot of other cool people that do math and science streams on Twitch. You can go check them out as well. All right, let's see. Who is going to win the next question that we go through?
Let's go gambling!
Who's going to be? Who's going to be? Who's going to be? Starvin' Marvin! Aw, Flash says, I have the best math stream on Twitch, IMO. Thank you, dude. I don't know if I have the best one. There are people that are much better at math than I am. I think I might have one of the most entertaining ones sometimes.
No, because all the other ones kind of suck. Because I've been through the other streams before, and like the only reason when I had first seen your stream, I was like, yeah I want to stick to this dude's stream. It's because there's not a single other streamer who will actually do people's examples.
Oh, interesting.
Like one of the first examples I had given, this dude, literally like a PhD math guy, teaches at a college, and he was streaming on TikTok. And I asked him if he knew how to solve it. It was like one of the first questions I had given you. Mm-hmm. I asked him to solve it. He looks at it and he goes, e to the...
Where'd he go? Sorry, you cut out for a second there. Oh, his headset died. No, it's really trying to be the best part of the story.
Inconvenient time.
No, dude. No, dude. It was the CIA dude.
Oh no.
The CIA dude.
E to the negative tan theta, and you know what he says? Doesn't even try the question. He goes, "I don't think I can do that."
Yeah.
And then
just like passed it.
Like,
just passed on. Wow.
And yeah, people would ask for like example problems. He just wouldn't do examples, and like a bunch of them do that.
What is he doing up there streaming, dude? If he's not answering questions, what?
Well, he was streaming it, and people would ask like, "Oh, well, I got a question about differentiation," and he would explain it for like 5 or 6 minutes.
Oh, okay. Yeah, I like to like learn by example. Also, like, I'm totally fine with looking really dumb and like trying to figure out stuff I don't know. I think it's cool. Flash says you incorporate so many various types and fields of math in a single problem. A lot of other streamers act like they're teaching a university course on a narrow subject. Yeah, true. Yeah. I like to call my streams like variety math and science. We do a lot of math, but I always appreciate the science stuff too. All right, let's see. Breasticles is getting his headset to work again. Figure 3 shows a sketch of the graph with the equation. Given that a is a constant and the absolute value of a is equal to 1, find the possible values of f of a? Oh, okay. Wait, okay. So wait, if absolute value of a is equal to 1, this is where I wonder if I'm getting tricked. Does this just mean a equals 1 or negative 1? Or do I have to do some shit where it's like e to the, like, something with thetas and pies and shit?
No. I don't think so. Because X is an element of the real numbers. So the only time that would apply
is they did say that.
It was included in the complex numbers. Because then your absolute value turns it from 2 points to an entire circle.
Exactly, yeah. We love circles, though.
But since it's an R, it's fine. You don't have to worry about it.
Thank you. I'm just cruising. You love what I'm doing. I appreciate that. Yeah, cool. All right. So possible values. So if a is equal to -1, I don't know. I guess I just check it out, right? So if a is -1, I have 4 times -1 minus 3 minus 5. This becomes -4. Absolute value of that becomes +4. +4 times 4 is 16. 16 minus 5 is 11. Or it could have been 1. And so that would have been 1 minus 3 minus 5. This becomes -2. Absolute value of -2 is 2. 2 times 4 is 8. 8 minus 5 is 3.
Oh, yeah.
Is this an A-level question? What is this? I feel like I know this formatting. This can't be A-levels. It's got to be like O-levels maybe. Great. Okay. The function g is defined by this. Find the range of girlfriend of x? What is this?
Surprise, motherfucker.
What is this? What's gf of x?
I think that's the composition. It's kind
You
of.
think this is g of f of x? I agree,
Yeah,
Jeff.
I think that's the composition.
Okay.
I think it's just. I haven't seen that notation.
You know what I always
It's kind
love
of ambiguous.
whenever they say like f of g of x breasticles, but then they like do it like this, and you're like fog. What is
Oh
fog?
yeah, I've always read it as fog.
Fog?
I prefer the first notation anyway because it's more clear, like
Yeah.
what's going
I
into
do
what.
Too many nerds in math to talk about girlfriends.
Oh no.
Yeah, it's okay. The girlfriend drought now applies even to the non-nerds. The whole world is fucked.
You're not that guy, pal. Trust me. You're not that guy.
Okay, find the range. So I think I have to figure out what the range of f of x would be, right? And then have that kind of compute into what g of x would be. So let's see. F of x, what is the lowest value f of x could be, right? Well, the lowest value would be when this whole part here is the smallest. And this always, I like to kind of like work backwards, thinking of a function as a bunch of little tools. So this part I know has a range of 0 to infinity, right? Because that's what absolute value does. Absolute value can never be negative. So it can only go from as small as 0 up to infinity, which means when I multiply it by 4, that doesn't change my range. My range is now 0 times 4, which is 0, to 4 times infinity, which is still infinity. So then it's 0 to infinity minus 5. Well, okay. The smallest that can be is 0 minus 5, which would be -5. And then, or it could be infinity minus 5, which is just infinity. Technically, yeah. Sorry. Yeah, technically I need a hard bracket. My bad. Yeah, there you go. Yeah. Oh, no. Don't delete that. Okay. So I can go from -5 to infinity. So that means looking here at g of x. So here, this goes from -5 to infinity. So the top end of g, well, that's going to be 2 times infinity. That's still infinity. So the top end of this... Oh, and sorry, it's not... No. See, Jeff, now I'm getting my parentheses and brackets wrong. This is this. Okay, the top end of g, the highest value g can be, is when x is the highest value can be. And that's when it's infinity. So that's going to be infinity. And then g is a nice linear increasing function. So the lowest value of g will happen at the lowest value of x, and that's at -5. So then -5 times 2 is -10. -10 plus 17 is 7. And there you go. Beautiful. H of x is defined as k times x, where k is a constant. Given that the equation f of x equals h of x has no solutions, find the range of values for k. Oh, this is cool. Okay. So wait, what was f of x? This is f of x, right? So we need to think about, and then this is, I need a different color. Yes, exactly. Well, it stays below it, so this is y is equal to k of x. And then depending what k is, right? So this always has a y-intercept equal to 0. So it can do like any of this, right? So let's think. I think when it's parallel, right? That's when it'll never cross. Right? Because if you just have like a parallel line from here, you'll never hit this. If it's slightly not parallel, right? Then eventually this top end would hit this. And then also well, I wonder you could have it slanted a little bit this way, right? Because maybe you like just barely miss this. Yeah, I think I see what I need to do. Okay. Is it really 7 though? What, did I screw up? Sorry, did I screw up? Wait, dude, what's all those answers? What? Is it theta?
That's 7, but in set theory, all those are empty sets.
And there's 7 of them.
Yeah, in set theory, they were like, hey, well, what's 0? 0 is a set containing the empty set. So what's 1? How about the set containing 0? So 1 is the set containing, or 0 is the empty set, and then 1 is the set containing the empty set, and then 2 is the set containing 1.
You're doing a bunch of nested sets. It's a bunch of nested recursion.
Yeah, it's a bunch of, yeah.
I can't believe you typed this all out.
Oh, I didn't. I went to ChatGPT and told it to
great,
type it
beautiful,
for me.
Beautiful. Okay. So yeah, so okay, if it hits the point where the modulus lines meet, does that count as a solution? Yeah. You're saying if it hits this point, that would be a solution. So here's my thought. My thought is this is definitely somewhere where there's no solution. So it's where this is parallel to this, which that would be something with a slope of -4, right? Because this kind of looks like y equals, that's a thick ass pen, sorry. This looks like y equals mx plus b, just with a shift on it. So yeah, -4x is definitely one of them, but then I think there are a range of other values that work. So I think this works for sure. But then I do believe you can keep going counterclockwise, or you can keep having a slope that's getting closer to 0 until
oh no,
you hit this, and then you're no good. Yeah, exactly. Jeff says you could tweak it until it almost touches the bottom there, right? Do you see how that, right? This can go from like this to this and eventually to that. So we should find the slope of this, and that's not too bad. If you remember what this tells you about like points wise, this tells you have a vertex at x is equal to 3, and then the y coordinate for that vertex is at -5. So I just need to figure out what the slope of this is, right? Well, the slope of that is y minus y over x minus x, and this point is just 0, 0. So that would be equal to y is equal to -5/3 x. Yeah. And this is like the quote-unquote most positive or least negative slope you can have. Because if the slope is any less negative, any less going down, then it'll hit it. So I think it's from -4 to -5/3. So yeah, I would say -4, which it includes -4, that's okay. But then it can't include -5/3. It gets right up to it. And that's why we put the parentheses there. Cool. This is actually really cool. I like this. This is a fun question. Great question. Thank you so much, Starvin Marvin. B squared minus 4AC works for quadratics. Yeah, you have the right idea there, Boomer, in terms of that would be -b over 2a. Here, I'll show you like the thing you're thinking about. Here, let me mark this as done real quick. Yeah, exactly. Yeah. So Jeff has the right idea, but you are totally right. So yeah, this is, I know it looks like a quadratic because it's kind of U-shaped, but it's V-shaped. And that sharp point there creates a vertex due to the absolute value. So b squared minus 4ac is not the correct thing you want to use. You are correct in this sense. If I say like the vertex of a quadratic, which is a squared plus b squared plus c squared. Let's see. Does someone have a nice diagram of it? Yeah. This looks kind of okay. There you go. So this vertex point, yeah, the x-coordinate for that is negative b over 2a. And then the y-coordinate is technically the determinant b squared minus 4ac. And then it's, I think it's over 2 or something. What do they do? You plug it back in, but I think effectively you are doing something with the determinant. Oh, here it is. Beautiful Q math. Yeah. The vertex is negative b over 2a. And then the y value is negative d over 4a. Random dude on Twitch says, I won't get any votes. Well, don't worry. You're the only person that can vote. Or, well, anybody can vote, but you have to vote every 3 minutes.
I gave you an upvote.
Yeah, there you go. Breasticles gave you an upvote. So, yeah. All you have to do is every 3 minutes you can go up here. You can just hit if you click the upvote button, it'll boost up your question. Okay, great. Let's do another one. Let's go choose a winner.
Joke's on him. He doesn't want shadow banned and by upvoting. He's never gonna win. My upvote.
Oh, dude, you got him close though. He's close.
That's dope.
Close. It's Gladiator. Oh wow, circuits. I like circuits. Circuits are dope.
That's dope.
I'm a fan of circuits. This is a multiple battery one too. Wow, Gladiator. Okay. All right, there we go. Frickin' physics.
Obviously, don't go and do that.
Now you do whatever you like.
We can't.
I like physics. See you, dude. See you, video games. Okay. This is a mess because I have a battery here and a battery here. Okay. The power dissipated in the 2 ohm resistor. So I know that P is equal to IV. So, yeah. I just need to find, in this case, I don't know, let's call this A, let's call this B, and let's call this C. I just need IB and VB. You could also say it's equal to I squared R. So actually, technically, I just need IB or VB, right? Dr. Gold. Thanks, video. Man, but this is a mess. Because there's a juncture here as well. Okay, I think I have to come up with a direction of current for things, right? Yeah. Okay. Man, because there's also a juncture here. Oh, no.
You done messed up.
I feel like this would be easier if we used one of like the node or like mesh methods, but I forget how they work. It's been so long since I've done them. Get frisky, throw in some capacitors. Yeah. I will use Kirchhoff's. Yeah. But I will definitely use Kirchhoff's law. So, let me think how I want to define the currents. I'm going to call this I1, which is all this, right? And then I'm going to have to I need to call another current something else. I'm going to call this I2. And then I'm going to call this I3. Okay. And then I think we just have to like kind of solve the system. So,
did you not write the 15 volt and the 4 ohm as a equivalent battery?
Yeah, you're saying like a battery with internal resistance?
Yeah, if you were to write it that way, then I think you would just get it to one loop.
If I wrote it as a battery... Well, no, it still wouldn't be just one loop. Because the issue is that they're meeting here and they're meeting here. Oh, wait a minute. Oh, you're saying if this meets here...
Yeah, I think...
Oh, then they're all in parallel with each other.
Closer there, yeah.
This is always the tricky thing, bro. This is always the tricky thing with E&M is like, or circuits. They'll make it look really complicated, but you can always move these junctures along lines as long as you don't cross another juncture. I see. Oh, this is even easier then. Okay. Sorry, I was getting all like fancy. Well, I think it's essentially the same. You have this in parallel with this in parallel with this, right?
Yeah, I think so.
Yeah, it's the same. I think you still want to define this as its own independent current, because this current is not going to be the same as this current, and it's not going to be the same as this current. It's like a superposition of the two. All right, let's do it real quick. This is easy. I don't know if it's easy, but I think it is. So let's do loops. Let's do some loops. So this will be 12 minus 4i1, right? Because we're going across the resistor in the same direction as the current. And then that's going to be minus 2i2, and then that's equal to 0, right? And then we have, for the blue loop, I'm going to have 15 minus 4i3, and then this is going to be plus 2i2 is equal to 0, because now we're going across the 2 ohm resistor here, but we're going opposite to the direction of the resistor. Yeah. Okay. And then, okay. So I have 3 unknowns. I need one more equation, and that comes from the juncture equation. And so what we're going to say is that current coming in is equal to current out. So I'm going to say that I1 is equal to I3 plus I2. So current coming in, I1, is equal to current coming out, I3 plus I2. Great. I can be lazy and just set this up as a matrix, maybe? Or actually, a lot of this stuff cancels, doesn't it? Let me think. 4i3. Yeah, I think so. Yeah. Here, I'm just going to plug this into here. So I'm going to get 12 minus 4i3 minus 4i2 plus minus 2i2 is equal to 0. And then here I'm going to get 15 minus 4i3 plus 2i2 is equal to 0. And so, what's that? 12 minus 4i3 minus 6i2 equals 0. And then this is 15 minus 4i3 minus 2 plus 2i2 is equal to 0. So now I can use systems of equations here to solve for I2. You just do this minus this. So 12 minus 15 is negative 3. Minus 6 minus 2 is negative 8. And so then I get that I2 is equal to negative 3/8 amps. Oh, so that's cool. So my direction here that I guessed was actually wrong.
Surprise, motherfucker.
And that should make sense, actually, right? Because this is a bigger battery. This is 15 volts pushing this way, where this is only 12 pushing the opposite direction. So yes, it kind of makes sense there. Okay, perfect. So yeah, I2 is equal to negative 3/8. That's the current going through the resistor. And then power is equal to I squared R. So that's just going to be 3/8 squared times the resistance, which was 2 ohms. So actually, this isn't too bad. So that's 9. That's 18 over 64. 9 over 32 watts. I want to say. Do we know if that's the right answer, Gladiator? Do you have the answer key to this one? Sometimes they have them. I can also I can send this at chat real quick. There we go. Solve. Just curious. Chat should be able to do this. I feel like this shouldn't be too hard. I feel like also breasticles, yeah, right? Because they're the exact same resistor and battery. I think maybe you just have like a net of 3 volts. Whatever, yeah. Yeah, here, they're doing nodes. This is node analysis. This is another way to do it. Let me make sure I got it. 3 parallel branches. 4 ohm resistor. 12 volt. Okay, good. 0.28. Is that the same answer we got? What's 9 over 32? I don't feel like that is the same. Oh, 0.28. Yeah, cool. All right, we did it. Great. Awesome. Nice. I like circuits. Circuits are cool. This looked harder than it needed to be, but I think it's always a good practice to label all your current branches, all your voltage loops, and just as long as you're consistent and you take your time and you're careful about what you label, it's just algebra at that point. Nice. Good question, Gladiator. I feel better about physics circuits now. Okay, dope. That was a fun one.
AP Phys, you can get like 30% of the question if you just write a KCL and then
a juncture, right?
KLR,
Or,
yeah.
It's
if you just
KVL,
write your rules.
I think it's KVL and then KJT.
Yeah, that sounds accurate.
Something like that. What's up, Jaden?
Good
If
job.
you just write them, they give you like.
Yeah, they're like, yo,
2 or
you
3
tried.
points.
You definitely tried.
Well,
All
they
right,
normally
let's-
give you like points for the POI,
POI? What's POI?
point of initiation.
Oh, okay. Yeah, circuits are always fun. I love circuits. Honestly, it's kind of what kept me in physics and put me into plasma physics. I just love electronics. They're really cool. But I didn't want to go as hardcore as to get like a double E degree. Like that was like too much. I was just like hitting it hard. I was like, nope. All right, let's go choose a winner. Who we got for the next one? Is it going to be
Let's go gambling!
what was it? The soil tectronics? Maybe the soil tectronics? Okay, Boomer. Okay, cool. Ooh, what? Okay. All right, let's see. This is math disguised as chemistry. Yeah, is it a wolf in sheep's clothing? What's the difference between the sine and the cosine rule? One is when you have 2 angles and 2 sides. One is when you have 3 sides and 1 angle. If you're talking about law of sines and law of cosines, I have videos on those, Jaden, by the way. If you go to our YouTube channel, if you hit search here and type in like law of sines, yeah. Here. There's a bunch of videos here on law of sines.
So when doing the law of sines and solving for a missing angle,
There
check
you
to
go.
see
There's
if
law of sines. And then if you want law of cosines, I have one as well. Or I thought I had it. I'm very sure I had it at some point. Did I not do law of cosines? I think I only did law of sines because law of cosines is pretty self-explanatory. I vote to
And
ban.
I think one of them has a special case. I forget.
It's a law of
which one
sines.
that
Yeah, I think it's a
Yeah.
law of sines has. It's because sine is only defined for quadrants 1 and 4, and so you can't get angles bigger than 90. But in triangles, you can get angles bigger than 90. So that's why it has to be like ambiguous.
Yeah.
Law of cosines will never fail you. Cosine is
Yeah,
in
I
one,
haven't
too.
used them since pre-calc, to be honest.
Yeah. All right, let's see. At 40 degrees centigrade, the ionic KW. Dude, I always thought K was just KW was just equal to 1 times 10 to the minus 14. It's equal to 3? Where'd that come from? What? Excuse me? What? Since when is it 2.92? No, it's in moles. Moles. Oh. Boomer says at 25 degrees, it is 1. Oh, cool. Yeah, this has to do with, like acids and bases. Give the expression for KW. Well, KW, from what I remember, is equal to the concentration of the hydroxide times the concentration of the hydroxide? Or do they say like hydronium and hydroxide? I think that's what it is. Yeah. And then the reason why, if you wanted to do this, like let's say you take the log of this, right? So let's just say, let's say you take the log. So log of KW would be equal to log of H plus OH minus. This is actually really cool. So if we remember, right, the logarithm of two things multiplying by each other is two separate logs adding. So this is log of H plus log of OH minus. And then the log of like 10 to the minus 14 is just equal to negative 14. Right? So then and then here's the cool thing here. So this is negative pH, and then this is negative POH. So if you multiply everything by negative 1, that tells you 14 is equal to pH plus POH. So this is kind of the fun complementary rule where if something has a pH of 3, it has a POH of 11. And if something has a pH of 10, it has a POH of 4. Yeah, it comes from the math. Like, this is what Jeff was saying when he said, like, this is math disguised as chemistry. It is. It's really cool, though, where it comes from. Yeah. Okay, here we go. Calculate the pH of pure water at 40 degrees. Oh, okay. Give your answers to 2 decimal places. Interesting. One sec. TikTok wants me to do things. I feel like I need one of the concentrations, though, no? Did you do the modulus question? Shush. I don't think so. Not yet. Wait, one sec. TikTok's really mad at me. It wants me to verify myself. There we go. Come on. Which one was the modulus question? They're in there. Oh, in pure water, H plus... Oh, okay. Very cool. I needed to know that. Thank you. Yes. Okay. Very beautiful. Okay, that makes so much more sense then. Okay, fine. Sure. So, okay. So we know this, right? KW is equal to this concentration times this, right? So that means that if H plus equals OH minus, then KW is equal to 2 times... Or, sorry, is equal to H plus squared, right? Right? It's H plus times H plus, which is equal to H plus squared. So, we could square root both sides, right? So the square root of KW is equal to concentration of H plus. And then if you want to figure out what the pH is, you just take the negative log of both sides. Yeah, exactly. That's what we're going to do, Kavyan. You're right. I'm just going to do negative log. Negative log of H plus, which that's equal to pH. So then we just need the negative log of this to the 1/2. So let's pull out a calculator. This is cool. I didn't know that KW, in all the chemistry I've taught, we always just say it's just 1 times 10 to the minus 14. I guess it does depend on temperature, though. It makes sense. Okay, so negative log of the square root 2.92 e to the minus 14. My guess is it's still kind of around 7, right? Yeah, 6 point... How many decimals they want? 2 decimal places? 6.77. Almost got the 6.67.
Oh shit, not good.
6.77, though. Sorry, guys.
Surprise, motherfucker.
Yeah, almost. The calculator's sick. Yeah, you like my TI-84 Gold Edition? Pretty sick calculator. Can't say those numbers around here. Okay, here we go. Okay, so we got a volume. First of all, this is in centimeters cubed. This is in decimeters? Dude, what? Why are they putting things in what the fuck's a decimeter?
What the fuck is this piece of shit?
Sorry, is decimeter like 0.1? Oh, a decimeter cubed is a liter. I didn't know that. I guess that makes sense. Because I know that 1 ml is equal to 1 centimeter cubed. I see. And you need it to be by 1,000. So that's 10 times 10 times 10. Right, okay. And then, yeah, I think there's 10 centimeters in 1 decimeter. So, 1 decimeter cubed is equal to 10 times 10 times 10, or 10 to the 3rd centimeters cubed, right? That's cool. And then this is 1,000 cc's. And then cc same as an ml, so 1,000 mLs, which equals 1 liter, which equals 1 decimeter. Cool. I didn't know that. Dude, what country, Boomer, are you from? I'm curious if this is the U.S. I don't think I've ever seen this. Okay. England, okay. That would make sense. Yeah, okay. So this is, I'm going to put this in, like, terms that make sense to me. 35 mLs of 0.15 molar, because this is moles per liter, is mixed with 20 mLs of 0.1 molar hydrochloric acid. The temperature of the solution is 40 degrees. Calculate the pH of the solution. Great. So this is an elimination reaction. This is not a buffer solution, because you have a very, very strong base hitting a very, very strong acid. So what we need to figure out is we need to figure out how many moles are in both cases. So let's figure out the moles of NaOH, because they're just going to cancel each other out. Yeah. If this was a buffer, you'd have to do like some Henderson-Hasselbalch and then like like rebalance shit and stuff. But okay, so this is going to be 0.035 times 0.15. So let's see what that is. 0.035 times 0.15. So that's going to be 0.00525. And that's moles. And then let's get the moles of HCl, which is going to be 0.020 times 0.1. So that's going to equal to 0.002 moles. So here's a cool thing. There's more base than acid. So the acid is going to like collide into the base.
Surprise, motherfucker.
And like destroy itself. But it's not going down without a fight, because as it loses all 0.002 moles of acid, it's going to take away 0.002 moles of base. So NaOH remaining, because the NaOH is the victor, is equal to 0.00525 minus 0.002, which is equal to 0.00325 moles. Right? Yeah, because you have NaOH plus H2O is just giving you H2O plus, I don't know, like, does Na just like, is it just positive Na? I think it's just actually, I don't know what happens to the Na. I think Na is like a spectator ion in this case. But the key thing is that this is your limit, not H2O, sorry, but this is, sorry, HCl. Oh, I'm dumb, sorry. It makes salt. That's what I meant to say. Yeah, there you go. It's a double replacement. Na and Cl bind together to form salt, and and then the H and the OH form together to form water. But HCl is the limiting reactant. So you use up all the HCl, but you're not able to kill off all the NaOH. So some NaOH is left, and that is going to be the dominant thing determining the pH of your liquid, because it's such a strong base. Also because this dissociates completely into Na plus and OH minus. You can say like dissociates completely. So basically, the concentration of NaOH is equal to the concentration of OH. Oh, you know what to do after this? Oh, this is easy. Okay. No, that's okay. So remember that POH is equal to negative log concentration of OH. So you're going to do the negative log of this. But
Oh no.
I almost made a mistake here. This is moles. I need a concentration. In order to get concentration, I need moles over volume, right? So concentration of OH is equal to 0.00325 moles divided by the volume. And the volume is the total volume of liquid that's there, which is now 35 plus 20 mLs. Okay? So that's really 0.00325 all over 0.055 liters. Okay? Or you could say moles over decimeter cubed. No, not yet. The OH concentration is equal to the NaOH concentration. So what's happening is NaOH plus HCl are eliminating each other. It's forming this and this. But because all the HCl is gone, the NaOH is now dissociating into Na plus OH minus, right? This is the leftover NaOH. This concentration, if you take the negative log of that, that'll give you the POH of the system. And then from this... Oh, I see, actually. I see. You know why? Because I'm assuming this situation where it's always just 14, but it's not, because your KW is technically different. I see, sorry. Once I get my OH minus concentration, I'm going to then solve for my H plus concentration, and then I'm going to take the negative log of that. So, okay, first things first. Let's get the OH concentration, and we do that by the amount of moles of OH that are left divided by the total volume that's there, that's present. And then I'll show you. This is funny. This is a little bit more nuanced. It's the first time I've dealt with a KW not being 1. Yeah, exactly. That would work for room temperature, which is what I'm used to, but... Yeah, you're good. This one is tricky. Okay, so this is 0.059 molar, okay? But... Yeah, we can't do POH yet.
Huh?
Okay. So then... I'm gonna say, what was it? KW, yeah. So KW is equal to concentration H plus times concentration OH minus, which is equal to concentration of H plus times 0.059. And then KW, right, was equal to 2.92. Right, times 10 to the minus 14. So then I'm going to move that over. I'm going to get the H plus concentration is equal to 2.92 times 10 to the minus 14 all over 0.059. And that's going to give me 4.94. Oh my god, chem with log. Isn't that just a piece of shit show in my dumbass brain? Yeah, you got it. Okay. And then pH is equal to the negative log of H plus. And so that's equal to the negative log of this. Which is going to give you 12.3. Which makes sense because it should be basic. How many decimal places? They want 2 decimal places. 2.31. 12.31. There you go. And that's it. That's how you do it. You're very welcome, Boomer. I hope that makes sense to you. It was kind of a fun one. And for the audience, I hope this kind of, you see the math of where like pH comes from. It's all just math. But yes, good job, Boomer. I'll save this whole screenshot into our Discord so you can go download it later if you want. Just check your work. So that'll get put in right here. Let's go to the geotechnical engineering. Let's see, dude. We got, what do we got? 27 minutes left. Might have time for it. But yeah, here's your screenshot, and then also if you ever want to go back and watch the whole stream, or you want to watch the part of the stream where we help you out, this is the link to the YouTube recording, and then it's also timestamped for you. I use some ChatGPT to vibe code that. I'm a big fan of vibe coding these days. I grew up on actual coding. Like, I had to actually code for my PhD and a lot of other things. But it's so useful now. If I have an idea of some cool feature I want to put on the stream and it hasn't been developed yet, I can usually get a working model of it within a day. Might be buggy, but it works. Answer 12. So alkaline side, yes. Yes, amo kayato. You're right. It is on the basic side. All right, let's see who the next question is going to be. We've got a couple submissions here. Oh, much worse? Yeah, Dr. Novice, I bet. When's your exam, by the way? When's the exam you're studying for, Dr. Novice? What day? Is it in like a month, or? Let's go choose a winner.
Let's go gambling!
Oh, August 10th. Oh, you got time. Got mad time. It's Jimmy. Jimmy, what do you got for me? Nice. Differential equation? Uh-oh.
Aw, dang it.
Random guy on Twitch is like, bro, when are we going to do the dirt question? We'll see, dude. Pure math. Okay. A large spherical balloon is deflating. Oh, wow. The Earth is turning flat. By the way, they did post the video of me debating with the flat earther. It's funny. I don't know if it's the best representation of what our entire debate was, because they cut so much out of it. It's only 13 minutes long. Also, this is not me. Also, I'm not a NASA scientist. They said, anyways, there's 25k views on this, so if you want to go watch this, I'm in this video debating this flat earther guy, but they kind of cut out all the scenes of me debating. So it's kind of more of an expose on like the flat earther guy, but he's cool.
Foucault pendulum here.
Yeah, but if you want to go watch it, it's kind of funny. I skipped the test about concavity today because I wasn't confident enough. Okay, all good. Do it when you feel like you're ready. Here, I'll post that link in there later if you guys want to watch it. Okay. Anyways, talking about spheres, like the Earth. At time t, it has a radius and a volume v. The volume is below it. The volume is modeled as a decreasing at a constant rate. Using this model, show that dr dt is equal to negative k over r squared, where k is a constant. Okay. The volume is decreasing at a constant rate. Okay, so that means that dv dt is equal to negative k, right? This is the rate at which the volume is changing, and we're saying the volume is changing negatively. It's decreasing, it's getting smaller, and it's at a constant k. Perfect, yeah. Okay, so then if I want to solve for, what do they want me to solve for dr dt? Oh, okay. This is actually a related rates question, right? Right, you have two rates, and you have an unknown one you're trying to solve for. So you need an equation that relates the two rate variables, which is v and r, which for a sphere, v is equal to 4/3 pi r cubed. This is where someone's gonna get mad at me for my differentiation stuff. But okay, so I implicitly derive this. So this is just going to become dv, and then this is going to become 4 pi r squared dr, and then I'm just going to put dt under both. Don't get mad at me. I'll do it. Sigh. Yeah, Jeff's. Okay.
Yeah, I'm with Jeff. It really hurt my soul to watch.
Okay, so dr dt is equal to 1 over 4 pi r squared dv dt. And then dv dt, right, is equal to negative k. So dr dt is equal to negative k over 4 pi r squared. What happened with the dt there? I just divided both sides by dt. Don't get mad. It works. Technically works. Really what you're supposed to do, okay, for the math people in the room, you're supposed to do ddt of both sides, and then you're supposed to recognize that this is a chain rule. So it becomes 3r squared dr dt. It's the same thing. You can do both ways. I need a second k. Why do I need a second k?
You would want to absorb your 4 pi into the k.
Oh, yeah. Into this. Yeah.
Yep.
Yeah. Well, that's
what we're going to say here. I mean, like, k is a constant. So in reality, we could call this, like, k prime, I guess. Like k prime equal k over 4 pi. So then
I think we just use k, because we're already given the original like differential equation with k.
Yeah, but then this thing needs to be 4 pi k, right?
Yeah.
I'll just be curious if they actually like want me to, you know, come up with like what the constant is that it's decreasing with. It's technically not k, right? It's 4 pi k. Okay, whatever. Yeah, okay, cool. Yeah, okay. Given that the initial radius of the balloon is 40 centimeters, after 5 seconds the radius is 20 centimeters, the volume of the balloon continues to decrease at a constant rate. Solve the differential equation to find a complete equation linking r and t. Okay. So dr dt is equal to negative k over r squared. This isn't too bad. Famish, what's up? Dr. Gold is gold. That's what you want for the ticker? All right, here, let me change it for a moment. 1 sec. Or is a gold? You want is a gold? Okay. I have to respect the tickers. There you go. You get the ticker. Okay. This is separable. So what I can do is I can move this over here, move this over here. And so I'm going to get r squared dr is equal to negative k dt. And then, so all I did is I just cross multiplied. And then we can integrate both sides. And so this is going to become r to the third over 3 is equal to negative kt and then plus c. Now to figure out plus c, I need to use my boundary conditions or here. So here they say the initial radius of the balloon is 40 centimeters. Okay. So that means when t equals 0, r equals 40. And then they also tell me after 5 seconds, the radius is 20. So when t is equal to 5, r equals 20. I think this is good so far, yeah? Okay. So if I plug in 0 for here,
Disqualified.
this goes away. And then I know r is 40, right? That just tells me that like 40 cubed over 3 is equal to c. Is that all I need to do? I don't even think I need this condition, do I? Yeah, I don't think I need it. Okay. So, what do they want? Sorry, solve the equation linking R and T. Well, this is the equation linking R and T. Oh, I don't know K. That's right. Yes. Sorry, I forgot I can't just leave K as K. Okay, yeah, sorry. That figured out C. Then I need this to figure out K. Exactly. I was wondering, I was like, why are they giving me both again?
Surprise, motherfucker.
I get it. Okay. Okay. So that was using this one. Then we're going to use this thing, this condition, to figure out K. Because if I use T equals 0, K just goes away.
Oh, no.
And we can't have that. So we're going to use that one. So in that case, I have 20 cubed over 3 is equal to negative 5K. Exactly. Thank you, genius. You are living up to your name. And then this is plus 40 over 3 over 3. Okay. So, I don't know. So, K is equal to 20 cubed minus 40 cubed all over negative 15. I don't want to live in this world of unresolved variables. Okay, so 20 to the third minus 40 to the third. Divide that by negative 15. And you get K is equal to 3733. Okay. 3733.3. Whatever, I'm just going to leave it. It's 3733. Okay, cool. So, yeah. Okay, so that tells me my equation. I can say that, so r to the third is equal to, and then let's multiply the 3 through, right? Let's just multiply the 3. Is equal to negative 11,200 t. And then if c is 40 over 3, then multiply by 3.
I think if you multiply by 3, that changes your k. Because your k was like a 0.33 repeating.
Yeah, exactly. Yeah, sorry.
So
this
multiplying by 3 would.
You get a whole number.
Add an extra 1. Yeah, but I think it would add 1 to it.
Well, I did it on the calculator here. I said the full thing times 3.
I see.
You're good. No, you're right. No, you're totally right. As it stands, what I was writing, yeah, it would add 1. Okay. And then this is plus 6,400. 64,000. Cool. Okay, and then find the limitation on the values for t, which is valid. Well, it's valid as long as the radius is positive, right? It makes no sense if the radius is negative. So, part C is valid until this cancels out this, because then r would equal 0. So we would say 11,1200 t is equal to 64,000. Let's divide those two. What if the balloon turns into a black hole? Uh-oh. Okay, so 5.7 t has to be less than 5.7 seconds. Nice. Cool question, by the way. Thank you, Jimmy. That was a really cool one. Beautiful, simple differential equation. Separable. Yeah. I'm building up my confidence.
Q was separable at one point.
At one
after
point.
some work.
Yeah, at one point. The ODE stuff we were doing earlier, although it did eventually lead to a separable part, which was nice.
Yeah, eventually it got there.
Random dude on Twitch says, "Show me the dirt." Show me the dirt. I hope you do get picked, random dude on Twitch. I really do. Godspeed. Let's see. Okay. Let's see what we got for questions. There's only 4 left. So it is very likely. Random dude on Twitch has... You got to remember to upvote here, dog. Come on, you got to remember to upvote. All right. Let's choose a winner.
Let's go gambling!
Ooh, it's no scope. It's okay. Random dude on Twitch, you're now at 30%. Let me see what no scope gave me. Oh, we know this question, don't we? Don't we know this question? I feel like we've been given this question before. No dirt for now. The answer is just 12. I love how it's ABG, Asian baby girl, dude. What? The area of the ABG is 30. It's a heptagon. Okay. What's a heptagon? Sorry. How many sides? 1, 2, 3, 4, 5, 6, 7. Let me think. Is internal angle equal to, I want to say it's n minus 2 times 180. Is that correct? Oh, and then divided by n, of course. Yeah. If it's regular, okay. So then this is 7 minus 2 times 180 all over 7. So 5 times 180 is not nice. I mean, it's 900. But the divide by 7 is gonna be kind of ugly, I think. Yeah. Ew.
Disqualified.
Okay. So that's going to equal 128. Let's say 0.6 degrees. So that's what I know this is, right? I know this is 128 degrees, basically 0.6 degrees. So then I could figure out this. I could figure out this from like the area of the triangle is 30. Calculate the length of GB. Oh, this is on a non-calculator paper. Oh, is it? Okay. Just stop in altitude. Boomer says he doesn't think it's correct. I was just figuring out what this angle was, because I figure if I figure that, then I know what this triangle is. No. This is called. I mean, I think there's like an apothem or something that happens, right? But okay. The length of GB. So GB times this divided by 2 has to equal to 30. Yes, Blessin, send me a question, dude. Let's call this X. Okay. So I know GB times X divided by 2 is equal to 30. How can I figure out what X is? I would say that X splits this. And then I know it also splits this. Oh, 3 sig figs. Yeah, okay. Right? Yeah. And then I know this, right? Okay. So then I have an angle. I know this is a right angle. I know at this angle because I know this makes a triangle as well. Okay, yeah, I think I get it. I get it. One sec. Let me explain how it works. Okay, yeah. Let's call this x. Let's call this I'm just going to call this thing theta, if that's cool. Okay? Let's just call that theta. All right. So then and then we'll deal with the variables later. So the whole thing is equal to theta. Then this right here is theta over 2. And then if this whole thing is theta, then these must be the same. Right? If we were to make, like, the big triangle. I don't even know if we need the angles, breasticles. You show me if there's a way to not do it.
Well, so what I was thinking is, since we know it's a normal heptagon, if we imagine that we take that triangle that we have there, lay one of those triangles on the GFE portion, lay one of them on the BCD portion. Other side, the BCD. Yeah.
Like that? Yeah.
And then we have a trapezoid there that we could solve for because we can figure out the base in terms of x. And then we could figure out what that E to D distance is, I imagine.
Oh, because you're going to say this is the same as this?
The area of a trapezoid. Possibly.
I see where you're getting at.
I imagine it's possible.
I see, because I know this side is equal to this side. So I could get this side. But then, wait, I still need to get this, though, is the issue. Yeah, you still need an angle, though, eventually. I think you do need angles, eventually. You take a look at it, see. All right, so if this is a triangle and these are equal sides, then it's isosceles, so these angles are the same. So this angle equals this angle. Or more importantly, this angle plus this angle plus a 90 have to equal 180. So I can say this is 180 minus theta over 2. Yeah, you can assume, because this is a perpendicular bisector, yeah. The fact that AG, this equals this, that does help us out a lot. Yeah. Because that tells me this angle equals this angle. Yeah, okay. So, alright, so GB times X over 2 is equal to 30. I need X. Okay. So I could get it from, I think I could get it from here, maybe? Wait a minute. Oh, okay. This is GB over 2 then. Okay, sorry. If this is GB over 2. Right? I see where this comes from. Exactly. Yep, you got it. This is GB over 2. So then, you could have done half a triangle is 15. Correct. Actually, no. You're very, very true. We could do that as well. Well, this is essentially what we have, right? GB over 2 times X is going to be equal to. So 1/2 of that is equal to 30. Sorry. If this is equal to 30, then 1/2 of this is equal to 15, and then that's essentially what this is. Yeah, I like that. Okay, cool. Let's do that. So I would say 1/2 GB times X over 2 is equal to 15. Okay. And then I just need a relationship between GB over X and 2. GB over 2 and X, I think. So what I can say is that from this angle, or actually, let's do it from this one, right? Yeah, I agree with this. Watch. So tangent of theta over 2 is equal to the opposite, which is GB over 2 over the adjacent. So that's GB over 2 over X. So that's GB over 2 over 2X. Yeah, exactly. Good. Okay. So now GB over, well, I want GB at the end of the day. So I'm just going to say that X is equal to GB over 2 tangent of theta over 2. And then I'm going to plug that in to here. So we're going to get that. So that's 1/8 GB squared over tangent theta over 2 is equal to 15. What grade is this? This could be geometry, honestly. It could be 8th grade if you're advanced in geometry. Okay. All right, and where theta was the internal angle of one of the sides of a regular heptagon. Okay, so let's just do 15 times the tangent of this angle divided by 2. And then we're going to times it by 8. Then we're going to take the square root. Cool question. I got 15.8 as well. Yeah, 15.79 technically. So yeah, so GB equals 15.79. Nice. Cool. I agree with that.
I'm not gonna lie, this entire time I thought we were trying to figure out the total area of the heptagon.
Oh. Can we send?
That's
Can you
what I was
talking
talking about, like the triangles on the side.
I
see.
see.
I was like, oh.
No, we're trying to find the length of GB, dude.
Yeah, that makes sense.
That would make sense. It's okay. I've definitely done questions where I thought they were asking for one thing, and then at the very end be like, oh, I solved for the completely wrong one. Definitely do it. No Scope says, I accept values from 15.7, 15.8. Great. I'm glad. No Scope, we put your question here in the Discord. So if you ever want to see like kind of our process for it, or you want to ask other questions, it's there too. To 3 sig figs, you're right. That would be 15.796. Can you send me JEE questions?
Oh shit, not good.
No, don't do it to me. Don't do it to me. Don't do it.
Dancer extraordinaire. Wow, whoa.
Yeah, don't do it. Oh, 3 sig figs. Okay, whatever. 15.8. Okay. You know why I got confused is because the last question on chemistry was talking about decimal places, not sig figs, which I found interesting. Chemistry is usually the most stickler of the classes that deals with like sig figs, but they only ask for decimal places here. Okay. All right, let's see. Jeff, dude, what are you saying? Okay. All right, let's spin the wheel again. I'm technically out of time, but I'll spin it again. Let's hope the dirt question gets picked, right? Random dude on Twitch. You have a 31.5. Also, Crab has a good chance. Ooh, man. What's happening here? Oh, this is physics though. This isn't terrible. I don't know if it's terrible. I'll have to see. Is it dirt time? We're gonna see. We're gonna choose a winner.
Let's go gambling!
It's not dirt time, not yet. It's Crab. I swear, dirt person, you have to be next, dude. It has to be. No dirt. Okay. Okay, the height above the ground is modeled by this equation. A, B, and alpha are constants. Cool. Given that the maximum height is 50, the passenger is 1 meter when the wheel starts turning, and it takes 720 seconds to complete one resolution. Find a complete equation to the exact blah, 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 blah. Okay. Does the person start at the bottom? This is actually kind of a question here, though, right? It is the person... They say when the wheel starts turning. I'm going to assume that's when they're at the bottom, right? They start at... Oh, at angle alpha. Oh, okay. Oh, okay. All right, I see. We're... Well, okay, and we also assume, I guess, they're starting at the... Well, actually, ooh, that's not the lowest point.
Surprise, motherfucker.
Oh, no.
Oh, that's annoying. Yeah, 0 is not the lowest. Do you see that? This is the lowest. A is not... I think A is 50. Because do you see how, it hits 0? No. So look here, Jeff. Right? This one is above. I agree. This one definitely hits. It hits 0. I think. So he moved the shadow band, yeah. Okay, yeah. So I do think A is equal to 50. All right, and then okay. But, okay, here we go. When t equals 0, h equals 1. That's from this statement. And 720 seconds to complete one revolution. That tells me that... So, b in this case is 2 pi over the period, which is going to be equal to 2 pi over 720. So that's 2 pi over 360. Yeah. Okay, so now we have h is equal... I mean, don't worry about the absolute value stuff. Well, actually, actually it kind of does matter, doesn't it? We're working in degrees. Yeah. Oh, sorry. Yeah, sorry. So I don't use 2 pi. Yeah, I use angles. Oh, interesting. Oh, I see what I have to do here. A is not 50. A is equal to 25. Wait. Oh, this is even weirder. Wait a minute. Sorry, because sine goes positive to negative, no?
Sine goes from 0 at 0 and then increases.
Yeah. It's not centered at 0. It's centered at h equals 25. Well, let me think about. Okay, but I still think A has to equal 50, because that's my amplitude. And H is... Does the modulus affect the value of A? It goes from 0 to 50 in a full cycle, and absolute value of sine goes from 0 to 1. A is half the amplitude? Wait. No, A is twice the amplitude. In this case. It's actually kind of tricky. Yeah. This would be more appropriate. I like this, maybe. Complex analysis rude me because I'd probably do all this math using the complex plane instead.
Huh?
Oh, man. Yeah, so the absolute value doesn't matter. Fuck. Okay. I am running out of time, is the only thing. Yeah, and I thought I could do this easily, but I can't do this easily. So, let me save this one for next time. I want to go look at the dirt question real quick, though. It's a cool question, Crab. I'm already over time, and I'm gonna be like really out of time if I try to solve it. Let me see what Random Dude on Twitch said. Let's see your dirt question before I wrap the stream up. Let me see. You were working on a lower bound collapse analysis or analyzing the stress acting on a frictionless wound. In a clay... Is clay-y a word? C-L-A-E-Y? With an undrained strength. This is strength of materials? Okay. Wow. Shear stresses. This is cool. Yeah, so you get shear when you have forces acting at different directions. Horizontal normal stress, vertical normal stress, magnitude of the shear stress. I feel like I could almost do this because it's kind of statics, no? Isn't this statics? I forget the equations for, yeah, this is good stuff. Femvox, I think, has done this stuff. I don't know what, like, undrained strength means. And I do see the shear stresses, though. That's cool. Anyways. Okay, random guy on Twitch. This would be fun. Okay, I really gotta go. So let's close out the stream. Cool. I am gonna stream on Sunday. I will stream on Sunday. It'll be my birthday, actually, on Sunday. We'll do a birthday stream. Anyways, cool. Thank you, everyone, for coming to Actual Education Officers. I appreciate all the questions and stuff. Sorry if I missed some at the end there. We do stream for 3 hours and then I run out of time. But you guys are awesome. Yeah, the alpha term is probably the hardest. Yes. So don't worry. Any question we didn't do today will also get put in our Discord. So if people want to follow up and kind of try to solve it themselves, more than welcome to. I appreciate all the learning. You guys are dope. If, again, very, very cool thing to do is to go join our Discord, because that's where all the questions are, and that's also where we organize all the events and stuff. So click that button there. You can also visit the streaming schedule to see all the different times people are streaming. So we will just have recess games on Friday. That'll be on our sister channel, actual gaming. If you want to come by and hang out, that'll be fun. Zach usually streams on Saturday, but I think he's taking this Saturday off, and then Sunday we'll have a stream as well. I might move the time here because I might have like a birthday dinner I gotta go to or something. I don't know. But in any case, I will make sure to stream at some point on Sunday for you guys. My JEE question? Yeah, I have kind of a ban on JEE questions. What is this? The value of... Oh, man. Cosine... What's all these angles, dude?
Huh?
What's going on here? Okay. Anyways. You guys are awesome. Let's go raid someone on Twitch. So, yeah, make sure... also from that link, if you came from TikTok or YouTube... Go find us on Twitch, because that's where we can go, like, raid people and have fun. Who are we going to go say hi to? We got a bunch of cool people. Let's go say hi to Nerduino. I like Nerduino. Nerduino's fun. Great person. Artemis updates. Artemis is dope. Cool. All right. Enjoy the rest of your week. If we don't see you on Friday, we'll see you on Sunday. Have a great weekend. Peace.
And I'm wondering, the responsibility, does it weigh heavy on you? Do you feel like, I'm just not going to go to sleep. I'm going to make sure that we...
Wingstop lemon pepper all